Imagine easily lifting a heavy motorcycle above your head with just one hand.
That isn't a superhero power. It is everyday reality on the moon's surface.
Gravity here is much weaker than on Earth, bending everyday laws of physics. But why do two neighboring celestial bodies have such a massive gravitational difference?
This video breaks down every secret behind lunar and terrestrial gravity in detail.
We will explore everything from math and physics to real human space experiences.
Get ready for a fascinating journey through space, starting right now.
The most famous figure everyone hears is that lunar gravity is 1/6.
Specifically, Earth's gravitational acceleration is 9.8 milliters/quarts, while the Moon's is 1.62 milliters/quarts.
The exact ratio between these two values is 16.5%, or roughly 1/6.
To understand why, we must separate two key concepts: mass and weight.
Mass is the amount of matter making up your body, which never changes anywhere.
Whether you stand on Earth or the Moon, your atomic count stays identical.
Weight, however, is the gravitational pulling force acting upon that mass.
If your mass is 60 kilograms, you weigh around 600 newtons on Earth. But on the Moon, that same scale drops down to just 10 kilograms.
Yes! Look at that! I am a new man!
So, what determines how strong a planet's gravitational pull actually is?
The answer lies in Sir Isaac Newton's famous law of universal gravitation.
Gravity depends on two main factors: mass and distance to the center.
First, regarding mass, Earth is a true giant in our cosmic neighborhood.
Earth has approximately 81 times more mass than the Moon does. Balance scale: one Earth balancing out 81 moons. The greater the mass, the stronger the gravitational pull generated around it. Space-time fabric warping deeply around Earth.
Based on mass alone, lunar gravity should be 81 times weaker.
So why is the actual ratio 1/6 instead of 81 times weaker?
That brings us to Newton's second factor, the celestial body's radius. Light beam measuring radius from core to surface on both bodies.
The Moon is smaller, with a radius about 1/4 of Earth's. Radius measurement, 6,300.
Standing on the lunar surface puts you much closer to its center.
Gravity is inversely proportional to the square of the distance. Being 4 times closer boosts gravitational pull by roughly 16 times.
Dividing 16 by 81 gives us approximately 1/6.
This interplay of smaller mass and shorter radius creates 1/6, both factors merging into a glowing 1/6 icon. Now let's see what this 1/6 gravity feels like in practice. First, consider free fall acceleration when objects drop toward the ground.
On Earth, a rock dropped from 5 meters hits ground in just 1 second.
On the Moon, that same rock takes nearly 2.5 seconds to fall.
Every falling motion on the Moon looks like a slow-motion movie clip.
If you jump 0.5 meters on Earth, you reach 3 meters on the Moon.
Your hang time in the air also lasts 6 times longer than normal.
Apollo astronauts tested normal walking and discovered something surprising.
Be advised, the regolith is slick here. Had a minor slip, but I'm stable now.
They developed a technique called the bunny hop to move effectively.
Keeping feet together and hopping repeatedly provided speed and stability.
What about sports? Imagine playing soccer inside a lunar dome.
A powerful kick could send the ball flying hundreds of meters effortlessly.
And it looks like it's miles and miles and miles.
His golf ball flew for miles, setting an all-time record.
Fascinating, right? But low gravity also triggers major biological changes. Our bones and muscles constantly fight gravity to keep us upright.
Living long-term on the Moon removes that constant physical stress.
Human skeletons quickly lose calcium and experience reduced bone density. Muscle groups, especially in the legs and back, begin to atrophy. Your circulatory system is also heavily impacted by low gravity.
Fluid shifts toward the upper body, making astronauts' faces look slightly puffy.
Interestingly, your spinal column decompresses and expands significantly.
You could grow 3 to 5 centimeters taller within weeks.
But returning to Earth brings heavy body sensations and severe backaches. Earth pulls on the Moon, but the Moon pulls right back.
This gravitational pull is strong enough to bulge Earth's oceans outward.
It creates daily rising and falling ocean tides across our planet.
Mutual gravitational forces also created a phenomenon called tidal locking.
Its far side remains hidden forever from our view on Earth. The gravitational connection between Earth and Moon is truly profound. In summary, 1/6 gravity creates an extraordinary world on the Moon,
where humans can leap high despite significant long-term biological challenges.
If you could visit the Moon, what would you try first? Comment below.